Sequence formulas. Let's take a simple sequence, something like this. You can see it's just numbers are starting on 3 and going up by 2 each time. Now the notation that we're going to use is the first number is going to be called U1, second number U2, and so on. Oops. So basically, a question that we might be interested in, for example, is what is the 100th number in this list if we continue it? So that number would be called U100, the 100th number in the list. Okay, and we might be interested in what that number was. And of course, we can see the pattern, so we can easily work it out using logic, some logic. But it would be useful to have a formula. Okay, now a formula, a general formula, is going to be UN. Okay, so you can change the value of n to be what you want. So if you want the 100th term, you would put n is 100 into the formula. Okay, so let's give you an example. So this sequence that I've got here, actually I know the formula is UN is 2n plus 1. And I'm going to show you later in this video how to kind of work out some of the sequences, the formulas, but let's just see how we can use them first of all. So if you want the first number in this sequence, you just substitute n equals 1 into this general formula. Okay, now when you replace the n by 1, obviously on the left hand side you'll have u1, and on the right hand side you'll have 2 times 1 plus 1, which obviously is 3. When you put n equals to 2, you'll get u2, replacing the n by 2, equals 2 times 2 plus 1, and that's 5. So you can see it's working. When I put the value of the term that I want into the formula, it's telling me the numbers in the sequence. So if I want to answer this question, what's the 100th number in this sequence, it would be easy because I would just substitute n is 100 into the general formula, and I would have U100 equals 2 times 100 plus 1. So it's actually going to be 201. Okay, so if you are given the sequence, it's easy to generate the if you're given the formula, it's easy to generate the sequence. So for example, it can be as complicated as you want. Let's say 3n squared plus n, something like that. So quite often they might ask what's the first few numbers in this sequence. So all you do is to find the first term, substitute n is 1. I'll just move that across actually. So n equals 1 into this sequence. So we'll get u1 equals 3 times 1 squared plus 1. So that's 1 squared is 1, 3 times 1 is 3, plus 1, so it would be 4. N equals 2, u2, 3 times 2 squared plus 2. You're replacing the n by 2. So 2 squared is 4, 3 times 4 is 12, plus 2, that would be 14. I'll just do one more. N equals 3, so u3, just using this, so it's 3 times 3 squared plus 3. Yeah, n is 3. So that's going to be 9, 27, 30. Okay, and you just carry on like this. So if you are given the formula, it's very easy to be able to substitute the numbers in, and it will tell you whichever term in the sequence that you want. So it's very simple. What is not so simple is when you have the sequence. Imagine you were given these numbers 4, 14, 30 and a few more, and you had to find this formula. That is a lot more complicated. This is a quadratic one because you have a squared, and we're going to do those later. Today we're going to do these ones. These are linear ones because they're going up by the same amount each time. It's going up by 2, so actually it's quite easy to work out the formula for these ones. Okay, so let's have a look at some different types of sequences that we should be easily be able to find the formulas for. And these are the ones you kind of have to spot or work out for yourselves. Okay, so let's look at the first one. Well, from yesterday we should spot that these are the square numbers. Okay, so sometimes it's a good idea to think about this is the first number, second number, third number, fourth number, fifth number, sixth number. And obviously, if you want to get the first number, it's 1 squared. The second number is 2 squared. Third number is 3 squared, 4 squared. So if you want the nth number in the sequence, n is just some letter that we're using, then hopefully you can see that it would just be n squared. Whatever the position is that you want in the sequence, you just square it and it tells you what the number is in the sequence. So in this case, un is just n squared, isn't it? And hopefully these ones you recognize them as the cube numbers. So the first number is 1 cubed, second number is 2 cubed, and so on. So the nth number would be n cubed. So the formula is un equals n cubed. Right, let's look at this one. This is slightly different. So here's the first number, second number, third number, fourth number, fifth number, sixth number. Now hopefully you recognize that these numbers are square numbers. They're all square numbers, okay? The problem is that we don't start on 1, we're starting on 4, okay? So if you think about it, the first number is not 1 squared, but it's 2 squared. The second number is 3 squared. The third number is 4 squared, 5 squared, 6 squared, 7 squared. Okay. So can you see that if I want the first number to be 4, I'm going to have to do 2 squared. And to get the second number, I'm going to have to do 3 squared. Third number has to be 4 squared. So in other words, can you see that I'm always squaring the number that is 1 bigger than the term number? So for example, to get the sixth number, I need to do 7 squared. So the question is, if I want the nth number, yeah, I'm going to have to add 1 to it first and then square it. Okay, so it's basically going to be n plus 1 and then square it. You see all of these numbers are just 1 bigger than the term numbers and then squared. So in this case the formula would be n plus 1 and then square that number, and you can see it works. Yeah. Okay, similarly for this one, 3, 4, 5, 6, 7, first number has to be 3, second number, third number, fourth number, fifth number, sixth number. So we can see that the numbers are, it's just 2 bigger than these numbers, isn't it? This list 1, 2, 3, 4, 5, 6. If you add 2 to all of these numbers, then it's going to give you the numbers we want. So the formula is just going to be n plus 2. Yeah, n is just the number of the sequence. So you can see with 6, if n is 6, the sixth number, 6 plus 2, it gives you 8. Okay, so sometimes we can do this, use this idea to find the formula for a sequence once we've recognized the numbers. Right, let's look at this one, slightly more complicated. Now let's do the bottom first, because the bottom, you can see, should recognize the bottom numbers in the fraction. They are the cube numbers. Okay, so if we want to generate the bottom of the sequence, we just need to do n cubed. Okay, 1, 2, 3, 4. Yeah, these are the n numbers basically. Yeah, And if you just cube those numbers, you'll get the numbers on the bottom of the fraction. What about the numbers on the top of the fraction? How do we get from the n numbers to these numbers? Well, hopefully you can see they're just one bigger, aren't they? Yeah. So it would be n plus 1 to get the top numbers, and n cubed to get the bottom numbers. So our formula will be this. Okay. Right, again, this one, number 6, this result have to be the first number. It's actually 2, isn't it? Then the second number is 2 times 3, which is 6. 3 times 4, 12, and 4 is, the fourth number is 20, isn't it? But can we see the pattern here? But we have to do it, here's our n numbers, and we have to work out, if I got to the nth number, what is the formula? Well, can you see that these numbers are the same actually? It's 1, this one's 2, this one's 3, this one's 4. So the formula will have to have n. So the first number is basically the n, isn't it? And I'm going to times by. Now it's 1 times 2, 2 times 3. Can you see that this number, the second number in each of them, is always 1 bigger than the n numbers? Yeah, 3 and 4, 4 and 5. So it's going to be n times n plus 1. Yeah. So for example, when n is 4, 4 times 4 plus 1 is 5. So it's working. It's just telling you the numbers in the sequence. So our formula in this case will be n times n plus 1. Okay. So in these types of ones, it's just a question of kind of spotting the pattern and then kind of adjusting it if you need to. Okay. Now, I want to look at arithmetic sequences, linear sequences. Now, what are these types of sequences? Well, if I give you an example, a linear sequence is one where you have just like this one, 4n plus 1. Where it just has an n in the formula. It could be multiplied by something, and there could be a number added or subtracted, but it's like a linear graph. If you remember, we're doing graphs. If you have y equals 2x minus 3 or whatever, that would be a linear graph. We know it's going to be a straight line because we just have x's, some x's and some numbers. It's going to be the same here. So, for example, this sequence, what is it? Let's just work out. The sequence would be, the first number would be 4 times 1 plus 1, that's 5. Second number would be 4 times 2 plus 1, that's 9, 13, and so on. That's the sequence, okay? So these are linear sequences. Now, obviously, if you're given the formula, it's easy to work out the sequence. So 3n minus 2, for example. First term will be 1. Second term will be 3 times 2 is 6. That will be 4. And then it will be 7 and so on. But what we need to be able to do is to go the other way. So if they give you the linear sequence like this, can we work out that the formula was this? Yeah, and if we give them this sequence, we need to be able to work out that the formula was actually this. Okay, now one thing that we can spot here is that every time I increase the n number by 1, can you see in the first sequence we're adding 4 each time? Yeah. The reason for that is if you make the n 1 bigger, that extra 1 is being multiplied by the 4 basically, and that gives you the increase. So the difference here is 4 between the numbers, and this number is 4. If you look at the second sequence we made, the difference between 1 and 4, that's 3. It's going up by 3 each time, isn't it? Yeah. So that tells you this number. So what this is telling us is that actually the number in front of the n is the difference in the sequences. Yeah, we could see that with a linear sequence, it's always going to be the same difference between the numbers. Okay, so that's the first thing to realize. Now, the next question is, how do we find the number on the end, which I'm going to explain now. So let's take a sequence. Let's use the same one, actually, 5. So you can see it's going up by 4 each time. So that tells us it's a linear sequence. So first of all, there's several ways to do this, but to show you a couple of different ways. We can see that the sequence is going up by 4, so we know that the formula has to have 4n in it somewhere. So I'm going to do 4n because if the formula was 4n, the first number would be 4, wouldn't it? The second number would be 8, 12, 16, 20. Yeah, if the formula was 4n, then the sequence would look like this. Now, what's the difference between this sequence and our sequence? Well, can you see that to get from the R numbers that we got for 4n to get to the sequence we want, we just need to add 1 onto it, don't we? So we then know that this sequence must be 4n and then plus 1. So that's one way to do it. Okay. Another way to do it is just to, well, it's a kind of a little bit of a trick. Let me just undo these. Yeah. Okay. Now, if you look at the first one, the 4n plus 1. Okay. Now, obviously, we put 1 into it, we get the first term. 2 into it, we get the second term, and so on. Now, what happens if we put 0 into the formula? What do we get? Well, when we put 0 into the formula, you can see that just from this formula, so in other words, we'd have to call it u0, wouldn't we? Because n is 0. 4 times 0 is 0, and we just get the plus 0 plus 1, so we'd get 1. Yeah? Now, what does the u0 mean? Well, the u0 means actually, well, u1 is the first term, so u0 must be the term before that. Okay? So it's this number here. So this is u1, u2, u3, u4, and so on. This number will be u0. And what we notice is that, of course, this number in the formula must be the same as u0. Okay, because when we put n equals 0 into a formula, this bit, the number of n's will always disappear. Okay, so what I'm trying to say is this. If you want to work out the formula for a sequence, now let's do a new one. Let's do 5, 7, 9, 11, okay, 13 and so on. Can you see that the differences between the numbers is 2? So that tells you that the formula must have 2n in it. And if we use this trick of looking for the term that's before the first one, what's the number before the 5 if you carry on this sequence? Well, it would be a 3, wouldn't it, obviously? Yeah, that's the number before the first one. So our formula must be 2n plus 3. And you can see it works. If we try to work out 2, 3, 4, the 5th number in the sequence, let's say, I would need to put 5 into my formula. 2 times 5 is 10, plus 3 makes 13. Okay, so for linear sequences, this is a good way to kind of work out a quick way that you can easily work out the formula. So let's do another one. So imagine we've got 7, 12, 17, 22, something like that. What's the formula for this sequence? This is the first, second, third, fourth numbers. Well, can you see it's going up by 5 each time? So it has to be 5n in the formula. And then we just find the one before the first one, the 0th term. And if it's going up by 5, we need to go down by 5. So that would be, can we see that that's a 2? So the formula must be 5n plus 2. Yeah. Now, sometimes the sequences are going down. So we may have something like 10, 8, 6, 4, 2. Okay, that's a linear sequence. What's the formula for this? Okay, well, what's the difference between the numbers? Well, this time it's going down by 2. So it's basically -2 each time. So my formula will have to be -2n. And what is the term before the first one? Well, if it's going down by 2 each time, the first number must have been 12. Sorry, the 0th one, the one before the first, must have been 12. So my formula is -2n plus 12. Or actually, to write it a little bit more neatly, we might want to write it like that. It's exactly the same thing, just swapping them over. It just looks a bit better. And if you test it, you'll see it works. So this method is quite a good, kind of quick, easy method of finding the formula for a linear sequence.